Hello, everyone. My name is Madhav Agni, and welcome to Spark Summit 2020. I work for Cerner company, and today I'm going to present on building data quality audit framework using Delta at Cerner. So a little background about me. So I started my career in traditional data warehousing and data mining and reporting, and then moved on to big data, Hadoop and MapReduce. And then currently I'm working in the cloud building data pipelines end to end. So I'm going to start with introducing what Beacon is. Beacon is my team and also the data platform. Then I'm going to talk about Beacon's architecture, and then I'm going to switch gears and talk about data quality, need for data quality audit, and then talk about Delta Lake, some of its features and how that fits into everything. And lastly, I'm going to present a demo with showcasing the framework from end to end. So Cerner is a healthcare IT company. So we sit at the intersection of health and IT. And it's in that place that we use emerging technology to engage individuals in their own health while arming clinicians with data that empowers them to deliver smarter care instantly. So we support our clients by providing data driven insights that enable them to make better decisions for better healthcare management. So Cerner is spread across the entire globe in more than 35 countries. And then we have 6,000 and more hospitals that use Cerner's systems. We have traditional EHR systems, cloud-based EHR systems, radiology information systems, etc. So what is Beacon? Beacon is an inventory of configuration items and asset. So when I say configuration item, I'm talking about a physical server, a virtual machine, network device, a storage array, a laptop, as well as the cloud resources. So it doesn't matter if it's AWS, Azure, our own private cloud resources. We are responsible for maintaining the data for all of this. So we capture the configuration item itself, as well as its relationships and attributes. So this configuration management system is what is called Beacon. So why do we need Beacon? So currently we have multiple tools at Cerner with asset and configuration management. So those are all disparate tools managed by different teams. So it makes it very hard to leverage the information, and Beacon brings it all together under management of one team. Our responsibility mainly lies in data and its data quality. So we have different use cases that are needed in order to function Beacon. One of the main thing is security. So to protect Cerner, we need to protect the perimeter. So to do that, we need to know where the perimeter is. So for example, next any day, if there's a virus that affects Windows Server, the first thing that you want to know is how many Windows servers there are. And then the second thing would be kind of attributes and data related to those servers. So to know that, we need to have all that information in one place. The next thing is costing and licensing. So without basically doing those estimates for licensing, we need to have that data in one place so that people can make decisions on top of that. The most important part is operations. So in our day-to-day operations, in configuration management, incident management, service management, this data is used. So this is Beacon's technical architecture. So Beacon has about 25 different data sources, and they are presented at the top. So we use a push and a pull model. So in push, we push the data from on-prem into the cloud using open source tool called as Rundeck. And in the cloud, we use orchestration service called as Data Factory. So Data Factory has multiple connectors. For example, if you want to connect to like an Oracle DB, SQL Server, FTP server, we mainly need to set up that connection in Data Factory, and it will start pulling that data. So once we gather all that data, we store it in Data Lake Store, which is in Microsoft Azure. When we want to process the data, we use Databricks. as well as ML flow for machine learning use cases. And along with that, we transfer some of that data into a SQL DB as well for some traditional reporting tools. And then we have Power BI, which sits on top of Data Lake and Databricks that we can directly use to report data out of it. And all of this is controlled by a central CI/CD pipeline where we, at the commit of a button, we push our code into cloud directly. So what is data quality and where does data stand among all of these things? So you can regard data as the foundation for a hierarchy where data is at the bottom level. On top of data, you have information being data in context. Further up, we have knowledge that is seen as actionable information. And on top level, there is wisdom. So as you can see, if you have bad data quality, you will not have good information quality. And with bad information quality, you will lack the actionable knowledge that you require in business operations and so on. Usually, it's not hard to get everyone in accordance and agree that we need some data quality framework to solve all these problems. And really, that's where you need to showcase the problem that lies in data quality capturing. So some of the reasons why data quality is important is because without that, employees are not going to work with their BI applications because they will not trust the data. And also, incorrect data leads to false facts and bad decisions. It is very important that we reduce the data silos that are present in companies because of multiple tools having data in different places. That was one of the most important reasons why Beacon was born. Also, for stricter compliance requirements like GDPR, you need data quality, otherwise there will be multiple issues. So this represents a perfect illustration of the problems in data. Many companies are still afraid of data optimization projects, such as data quality and master data management initiatives. The organizational, procedural, and technological adjustments that have to be made can seem too complex and incalculable. On other hand, companies that successfully run their data quality and master data management initiatives achieve their success because they simply took the decision to launch their initiative and then evolve it step by step. Don't forget, data is now the most valuable resource we have in the world. So let's switch gears and talk about Delta Lake. So if you don't know already, Delta Lake is an open source storage layer that brings ACID transactions in Apache Spark and big data workloads. So it works seamlessly with your streaming as well as your batch use cases because you don't need that Lambda framework in order to split your data workloads. It all works together under one platform. And then you can also bring your own data lake to it. So for example, if you have it in Azure or AWS or traditional Hadoop, it works everything in accordance. So some of the features of Delta Lake, the main one being ACID transactions, but I'm going to focus on some other features like time travel. So it's basically a data versioning system where you can go back in time and figure out what the data look like, basically a snapshot of data. So I'm going to talk a bit about it in my demo later. The other one is audit history. So similar to time travel, you can pretty much see the full trail of audit on all of your data sets that you have enabled Delta for. And the main thing I'm going to talk about are your updates and release. So, when you do traditional warehousing, you can use that merge statements to do those upserts. And Delta Lakes makes it easy to make those merge statements happen. So this is the overall audit framework that I'm going to talk about. So first thing we have is the Azure Data Factory. So that is the orchestration service that we use to do all the data flows from end to end. So we use Data Factory to kick off the Databricks notebook, which is in this case would be a Delta Lake notebook. It will do the audit that we set up in the notebook, and then all of the tables that will get refreshed will be used in Power BI. or some after the fact reporting. And based on that, we have set up alerts on some of the audits so that we don't actually have to go into reporting to look at the data issues, but the alerting system would alert us on when an audit would fail based on the parameters that you set up. So one thing that is important is that you can switch other tools that you use along with Delta Lake, making sure that the integration works fine among those. It's not like you have to use this exact same workflow in your company. So what was the impact of this data quality audit framework? We saw that there was an increase in pre-prod defects. When I'm saying pre-prod, those are the defects that your dev teams log before you go into production. So you'll want to make sure that that ratio of pre-prod to prod defects is much higher. Also, our SIE test execution. So developers write at SIE test plans to do some data validations. So instead of writing those individual test cases, they were able to leverage this framework. So that made them spend less time in writing new test cases every time, but just focus on enhancing this audit framework. One more advantage was that every time we used to do a new data audit before, that involved a code change. So a code change meaning we had to submit a change request every time we do a release. But after moving to this updated framework, it was just a configuration change for us to add a new audit every time. So that caused a reduction in the change request as well. The main thing was we did not have to depend upon my stakeholders or data analysts to find defects in data. We were able to find them ourselves before it reaches to the stakeholders. So that made that our overall prod defects had reduced by almost 25%. So data rollbacks is something that was very new to us. A lot of times when we were sending data to external system, there used to be data issues. So we used to do code rollbacks, but there was not a good way of doing data rollbacks. So I'm going to talk about it in my demo as well, but it was the ability of just going back in time and sending the good data back as a rollback. So with that, I'm going to jump into my demo that will talk about this entire framework from end to end. Let's start with Azure Data Factory. So we use Data Factory as our orchestration service to organize all our data flows and its dependencies. So that is from data ingestion, data processing, running ML workflows. We use Data Factory to orchestrate everything. For this demo, we'll use an example of a commit system data set. So the use case over here is that internally, after our processing is done, we generate a commit system data set and create a delta by comparing it to an external system. And then we use audit to capture any data issues related to that delta. And if that delta looks good, we send that delta to the external system using an API. So over here, I'm going to talk about one of these pipelines over here. So if I double click, I see that I have 3 notebooks over here. And then the audit notebook is the one that gets kicked off after my staging tables get generated. So I'm going to talk about the audit datebook in this tab over here. So this is Azure Databricks runtime environment. So for using Delta, I don't need to do anything specific. It is included in the runtime itself. So over here, I'm just trying to import all the libraries that I need for downstream processing, creating datetime partitions. And this method is to connect to Data Lake Store. So we use Data Lake Store to store all our data in terms of files of different types. And then for this audit demo, I have a audit query file that I store in Data Lake Store. So for this, I have created a method to connect to Data Lake Store. So it will use my credentials to connect to Data Lake Store, generate a token, and then connect to it. The other method is to connect to our SQL DB. So as I mentioned, I need my staging tables it will generate credit from the pipelines and try to find data issues in those. So I'm connecting to that SQL DB using this method, and then I'm defining a couple of more methods, one to read the table and then create a temporary view out of that table. This is my main function. I'm passing all my credentials and my table names that I need, and then it will try to connect to DB and read all the tables, cache those, and then create data views on top of that. So this is the main part. So the first step I'm doing is I need to create a dimension table to capture my audit, and that dimension table I'm creating using delta. So this is create table if not exists. I'm specifying all the attributes that I need, and then for using delta, I'm just specifying the delta keyword over here, and then I'm partitioning my table by year, month, and day. Similar to this, I'm also creating a fact table to capture some of the counts. So after all of this is done, I'm also trying to do some trend analysis in Power BI. So for that purpose, I'm creating a fact table using a count. And then this is also a delta table that is partitioned by year, month, and day. And then for all the issues that we're trying to capture, I'm creating a specific table for that. And what that will host is just the main attributes that I need and what is the data issue that it belongs to. That is also a delta table over here, and then I generate this table every day. So the main advantage of having delta table is you can run these merge commands. So for the people who have used SQL stored procedures before, these commands would seem similar, and it's the same syntax that we already know of. So it's merge into your target table, which is in this case my dimension table, using my source table, which is the SACE table, and then I'm defining my key for my upsearch. So in my case, I'm using two ID columns that form the key, and then I'm also since everything is date partition, I'm using that date partition as part of the key. And what I'm doing is I'm saying if it matches my target table, then just update my timestamp. Otherwise, insert those rows into my target tables. I'm inserting all my attributes over here and specifying the values. So this is a standard syntax with delta. You can specify multiple conditions over here. I'm just using a standard upsert condition. You can also do deletes if you need to. In my case, I don't have a use case for it, so I'm just using the upsert method. So once I do my upsert, I'm going to come back to this command a bit later. So what the main thing I need is, once I have all the data in my dimension tables, I need to generate audits. So when I say audit, it can be a data analysis audit. So when you know something is wrong, you try to create a query for it and then insert that query into my audit table. I'm going to also show an example where I can run an ML model on top of my Delta notebook, and the audit that it captures I'm going to show is as part of my audit query as well. So to make this reusable and having not to do any code change in the future, I'm storing all my queries in Data Lake Store as a CSV file. So this way, whenever I want to add a new audit, I don't have to modify this code to generate that audit. I simply have to do a config change, edit that, add a new query, and save that file. So what this does is it will point to this path, and then it will create a pandas data frame, convert the query file into a list, and then it will in a for loop it will run those queries one by one. So to know what it looks like, I'm gonna jump into Data Lake Store. So this is the path it was referring to. So this is just nothing but a CSV file with all the queries that I need in my audit framework. So I've downloaded that file. So it kind of looks like this. So instead of running insert queries into the notebook, I'm just creating a text file, and then this will capture anything new that you add, and that will automatically be added as part of my audit framework. You can define the type of audit based on your team's needs. So in this example, I'm trying to capture some missing information in my data. So for my use case, if my data has any of these three attributes missing, this will fail my API call. So what I'm saying is I'm selecting those rows where either of these three columns are null, and I'm inserting that into my audit table. Similarly, another common type of audit is duplicates. So in this case, the delta that is generated, I'm trying to find if any of those rows have duplicates in those. So I'm trying to run this query based on the ID where the natural key does not match. I want to flag it as a duplicate entry. So once I have those duplicate entries, I'm inserting those into my audit table. So these are good examples when you know that something might be wrong with the data. There are other examples you might not know if something is wrong with your data. So a classic case is trying to find anomalies, different types of anomalies in your data. So in my case, I'm trying to find out if all the serial numbers that I have in my data sets are correct. So for this, I'm going to use ML processing to calculate z-score for my serial number attribute. So this is part of ML flow framework inside of Databricks. So for this, I don't have to do anything separate, but ML flow is included in Databricks. So I will generate that ML analysis and then create an audit on top of that to find out what are the anomalous serial numbers in my data set. So for this, I'll jump back to Databricks, and then so this is the command that is doing some pre-processing, and then it is trying to calculate z-score for one of the attributes. So once that z-score is calculated, I'm essentially saying that for all the records that have z-score of greater than 8, that is something that we have defined. Capture those and then create a temporary view, and then I'm going to use that temporary view in my audit table over here, saying for all those anomalous records that you find, insert that into my audit table. One other important thing that I talked about during my presentation was that the ability to sort of go back in time using their time travel option in Databricks Delta, and then doing a data rollback. So what I mean by that is that using the history command for a Delta table, I can figure out the entire history of that table since inception to the current state, and it will tell me the version number, the timestamp when it was created, and what was the operation. So what I can do is, if I need, I can go back in time and then load the data as of that particular version. So for example, one time we encountered data issues when we sent our delta into the external target system. So we wanted to essentially do a rollback. Now you can do a rollback easily for code, but not data. If you're trying to do a rollback for data, it's mostly a manual operation where you're trying to figure out what all things you were inserted and updated, and either do a delete of all those operations, or manually create queries to sort of undo all those operations. Now, the great thing about Delta is that I can just select all the records that I need and specify a previous version. So in this case, I'm saying pull all the records as of version 140. Now,
What this will do is it will look at your version and then basically store all that data into this query, which then you can use to load into your external system. Once all my data audits have been populated, I'm going to use Power BI to see and report on that data. So I'm using Power BI's Spark JDBC connector to connect to my cluster and then specify the DIM table that I created just now, and then load all that data and refresh it into a Power BI dashboard. So this is a good way for our data analysts or even your team to look at all the audits that you created in the previous step and do some reporting on top of this. And also you can send alerts based on this. So if I want to alert my team in Microsoft Teams or any other platform, uh, you can do that using Power BI refresh. And then this is kind of what it looks like, that it will send an alert whenever there is audit running, and it will capture counts, or if you want to do a separate type of audit and an alert, you can do that as well. My main thoughts are so you don't have to use the same services that I used in this demo. If Databricks is your central processing framework, you can use the frameworks that are a part of your tech stack. If you are working out of AWS, you can use S3 in place of Data Lake Store and use their orchestration service, and it will work fine with all those services as well. That concludes my demo. Thank you for your time. Let me know if any questions. Thank you.